Hello, everyone. So, welcome to this new session. Today, we'll be discussing and we'll try to explore about the matrix operation in MATLAB. Uh, Matrix, you must have studied in class 12 mathematics, and even in class 10, there is some introduction to matrix. Matrix is a collection of data, and most of the data analysis and data analytics work are done using matrix operation in MATLAB. So matrix has a lot of application. You have to understand matrix properly, and then only you'll be able to explore MATLAB properly. So this fourth session of MATLAB here in the previous session, we have already covered the essentials like setting up your MATLAB account. Then we have also discussed about variables, the basic commands. Now we'll be diving into the core of the MATLAB functionality, that is the matrix operation. MATLAB is the short form of Matrix Laboratory, which was especially designed for matrix manipulation. So, in this session, we'll gain some hands on experience with matrices, which are essential for engineering computations in the fields like control systems, signal processing, data analytics, and all. So, what is the objective of this session? We'll create and manipulate matrix in MATLAB. Then we'll also perform matrix operations such as addition, subtraction, multiplication, division. We will use built-in MATLAB functions for advanced matrix operation, transpose, determinant, inverse, etc., and solve a system of linear equations using matrices. So these are the four things that we'll be exploring today. What are matrices in MATLAB? So a matrix is a two-dimensional array of number. In other programming languages, we also call it a multidimensional array. And MATLAB treats everything as a in matrix and array. So you can use matrices to represent data, solve equation, perform mathematical operations, and many more. So how do we create a matrix? We create a matrix. You can define matrix in MATLAB using a square bracket. Rows are separated by semicolon and columns are separated by commas or spaces that we have already discussed in the previous session. So we write A is a matrix, and 1, 2, 3 are the three values. This is the row vector, and for the column vector, we write it this way: 4 is equals to B is equals to 4 semicolon 5 semicolon 6. So these are the two types of row vector and column vectors are the one-dimensional array. And when we create a two-dimensional array, that is matrix is written like this: 1 comma 2 is the first row, and 3 comma 4 is the second row. Similarly, you can see A is defined as 1, 2, 3, 4. B is defined as 5, 6, 7, 8. Then we can use for addition, C add is equals to A plus B. So better to go to the MATLAB and apply these things. So I'll come to the command prompt directly, and I'll write A is equals to, you can open the square bracket 1 comma 2, then we are giving a semicolon 3 comma 4, and then we are closing the bracket. So you can see 1 2 is the first row and 3 4 is the second row. Why this is happening? Because after 1 and 2 we are giving a semicolon, so it is happening like that. Similarly, if we are writing B is equals to like 5 comma 6 semicolon 7 comma 8, then similarly we get a P matrix. So this is how we create a matrix. It can be a three-dimensional matrix as well. Suppose we write C is equals to, now we can write 1 comma 2 comma 3, then semicolon 2 comma 4 comma 8, then semicolon, then 3 comma 6 comma 9. This is the you can have 3 cross 3 matrix. So there can be a 2 cross 2 matrix, there can be a 3 cross 3 matrix. As per your requirement, we can uh, define the matrix. So this is the first thing that we have to learn today, how to define matrix. Like in the objective, we have discussed that these are the 4 things that we'll be discussing today, creating and manipulating matrix. So this is how we create a matrix. Now that we have created matrix, the basic matrix operations are addition, subtraction, multiplication, division. So if A and B are two matrices where rows are separated by semicolons and columns by commas or spaces, addition of the matrix is done like this. So let us perform the addition and subtraction. Let us go directly here. We have A, we have B. Now suppose we write D is equals to 1 comma 1 comma 1 comma 1 semicolon 2 comma 2 comma 2 semicolon 3 comma 3 comma 3. So we have mm, sorry, we have C and D, two matrices. Now we want to add C and D. When we add C and D, what will happen? This value 1 will be added with this value. Okay, this value 2 will be added to this value. This value 3 will be added to this value. This is how matrix addition is performed. 2 plus 2, then 4 plus 2, then 8 plus 2, this will happen. So we write, suppose we write M underscore M addition is of C plus D, then you can see that 1 plus 1. This one plus this one is added here. Then 2 plus 1 is coming here. Then 3 plus 1 is coming here. And this way, the second row will be added, the third row will be added. Similarly, we can subtract. So if we write M underscore subtract is equals to C minus D, sorry, C minus D, then the subtraction of matrix will happen similarly. So you can see that 1 minus 1 will be 0. Here 2 minus 2 will be 0. Here 3 minus 3 will be 0. So you can see first row, first column is all 0. Excuse me. Then 2 minus 1 is 1. Similarly, this 2, 4 minus 2 will be 2, 6 minus 3 will be 3. So you can see 1, 2, 3. Then here you can see 3 minus 1 will be 2, 8 minus 2 will be 6, 9 minus 3 will be 6. So 2, 6, 6. So this is how addition and subtraction of matrix you can perform. You can also perform on two-dimensional matrix, or you can also perform on three-dimensional matrix. So it depends on what type of matrix you are creating, and then accordingly you can perform the matrix operation of addition and subtraction. Now let us come to explore more. So I'll come here. This we have discussed. Now let us see matrix multiplication. So for matrix multiplication, the number of columns in A must be equal to the number of columns in number of rows in B, because matrix multiplication is done rows by column. So this is how it is done. The result in a matrix where each element is dot product of the corresponding row from A and B. So if we multiply A by B, so it will be 1 into 5. This 1 will be multiplied by this 5 plus 2 by 7. So 1 by 5, 2 by 7 plus uh, this is how this first value will be coming, 1 into 5 plus 2 into 7. Then the result will be like this. So if we want to perform this, let us come to the here and let us create. Suppose we write A1 is equals to 2 comma 3 and 3 comma 4. Suppose this is A1 and we have B1 is equals to like 1 comma 1 and comma 2. So this is now. So if we write C1 is equals to A1 into B1, this is matrix multiplication, then what will happen? Uh, you can see that this is the value of C1. Okay, like here, you can see we have a, we can write it this way C1 underscore mul is equals to A1 into B1, and we have, you can say C1 mul this way. So the values are stored here. Now, if we try to understand how this first value 8 is coming here, so if we multiply 2 into 1 plus 3 into 2, so first value will be 2 into 1 plus 3 into 2. So 2 into 1 is 2 plus 3 into 2 is 6. That makes it 8. So you can see first value is 8. Now similarly second, 3 2 into 1 plus 3 into 2. So second value will be also 8. Now the if we move to here, second row, 3 into 1 plus 4 into 2. So 3 into 1 will make it 3 and 4 into 2 will make it 8. 8 plus 3 is 11. So 11 comma, and again here you can see 3 into uh, this is 3 into 1 plus 4 into 2 will make it 11. So this is how the multiplication of matrix is done, and we are getting the result. You can see in the workspace, we are getting the multiplication. Okay. So this is about matrix multiplication. Now you can also do element-wise operations. Element-wise operation means suppose you want to multiply first element of one element of matrix by exactly similarly by the other matrix, then also it is possible. You have to use the dot operation. And so element-wise multiplication is dot into element-wise division is dot by. So if we want to see it, we can come here. You can see we have A1 and B1. Now for dot operation, we write suppose D is equals to A1 dot, suppose A1 dot multiplication and V1. So this is the dot operation. Now you can see that it is 2 into 1 is coming 2, then 3 into 1 is coming 3, then 3 into 2 is coming 6, and similarly 4 into 2 is coming 8. So this is element wise. So if we want to multiply element wise, like addition and subtraction is done element wise, but multiplication of matrix has its own rule that we have just discussed. But if we want to perform multiplication or division element wise, then we can write dot multiplication or dot division. If we do not write dot, then it will be normal multiplication. If we use dot, then it will be element wise operation, multiplication operation. Similarly, you can try for the division as well. Now, transpose of the matrix is one very important thing that we have to understand. That transpose means changing the rows into columns and columns into rows. Here you can see, suppose we have a original matrix of A1, 2 is the first row, 3, 4 is the second row. Then if we find the transpose, this is the symbol for transpose. Then if we use the transpose, then what will happen? The rows will become columns and the columns will become rows. So this is how it is like this is how it is written, and this is how it is done. You have to use the transpose of this single quotes, and it will be the transpose. So if we have a matrix and we want to find the transpose, we can write the transpose and we'll get the result. So let us declare okay, I'll be using suppose CLC. Now suppose we have uh, A is equals to 1, comma 2 and 3, comma 4. So what we get? We get this matrix. Now to find the transpose, so we write A underscore transpose is equals to, we write A and then we give single quotes. Then we get the transpose. The transpose, you can see the rows. This is the row. This has become the column. This is the row. This has become the column. So changing the rows into column, column into rows makes the transpose of a matrix. And in MATLAB, it is done very easily. You just have to remember the command. So transpose is done. Now inverse and determinant. So inverse we can create using the inv function, and determinant we can create using the det function. Similarly, as we have find out the inverse using the command single quotes. Similarly, we can use the inverse using INV. INV and DET are the library functions to find the inverse and the determinant. So you have to first understand what is inverse and what is determinant. So here the very simple definition is that the inverse of a matrix A is satisfies this identity. A multiplied by the A inverse is the identity matrix. Similarly, determinant of 1, 2, 3, 4 will be 1 into 4 minus 2 into 3. This is how the determinant is calculated. And for your convenience, that if you have like forgotten the inverse and determinant, because we study matrices usually in the 12th and in the first year of engineering. So it might happen that you are not remembering it. So for your convenience, what we have done is we have put in uh, at the bottom, you can go and find out who the explanation of determinant and the explanation of inverse of matrix we have given at the bottom. So you can go and explore. But here you can see that suppose we have a matrix A with A, B, C, D, then the determinant will be A into D minus B into C. Similarly, if it is a three-dimensional, then we multiply the first column by the remaining four values. So if here we have 5, then 5 into AD minus BC, then similarly. So you have to first understand what is determinant. But if you want to find the determinant of a matrix, it is very easy and it can be very easily done using the INV and DET functions. So let us find out the inverse and determinant. So I'll directly go to the command window, and here we already have this. Then suppose we write A inverse is equals to INV, and then in the bracket we write it this way. So there's the inverse of A, and if we want to find the determinant, then we also have the formula for that. Determinant is equals to DET. You just have to remember DET, and you get the determinant is minus 2. Now 1 into 4 is 1 into 4 is 4 minus 6. 4 minus 6 is minus 2. Now suppose we have a three-dimensional matrix. Suppose we have A is equals to 1, comma 2, comma 3, 1, comma 2, comma 3, then 2, comma 2, comma 2, then 3, comma 3, comma 3. Suppose this. and we want to find the determinant. Then we write it A underscore uh, determinant is equals to det of A, and you get it is coming to zero. Now, how it is coming to zero? This one will be multiplied by these four value. 2 into 3. 2 into 3 is 6 minus 2 into 3 is 6. The 1 into 6 minus 6 0. So it is 0 plus 2 into will multiply 2 by 3 and 2 by 3. This 2 will be multiplied by this and this 2 will be multiplied by this. So it is 2 into 0. Similarly, if we have 3, then 2 into 3 minus 2 into 3. These four values will be taken. This 2 value and this 2 value will be taken for multiplying by 3. So you can see the determinant is coming to be 0. So this is very important that you understand how determinant is calculated, how inverse is calculated in mathematics. And here you just, if you have to find the determinant, you have to find the inverse, you have to find the transpose of the matrix, all can be done using the single commands and you get the result. You don't have to know the complete formula, but it is always better that you understand what is determinant and what is inverse. And for that, we have given some options for you to revise your concept of determinant and inverse. Now, there is a very important uh, usage of MATLAB that you can solve equations and find the value very easily using determinant. So let us see that also, finding the solving equations. Linear equations can be solved. This is the sixth thing that we are learning today. Now, suppose we have a equation like this: 2x plus y is equals to 8 and x plus 3y is equals to 18. I'm giving you 1 minute. Just try to go through this first, then I'll explain. Okay. So you can see that the values of the x and y, the coefficients of x and y of both the equations are represented by a matrix. And similarly, 2, 1 is here, 1, 3 is written here. And the value of on the RHS are written on in B. Now, suppose you have to find the value of x and y. What will be the value of x and y? This is how you have to solve the equation. This is very easy. First, I'll show you how we solve it manually. So if we have equation 2x plus y is equals to 8, x plus 3y equals to 18. Sorry to say, I'll go to my God. Yeah, I'll solve it here for you. Now, suppose we have two, just we have 2x plus y is equals to 8. And then we have x plus 3y is equals to 18. So these are the two equations. So what we do, we multiply the, we have to make the coefficients same. So what we will do, we'll multiply the equation 2. Suppose this is equation 1 and suppose this is equation 2. So what we do, we multiply equation 2 by 2. So it will become 2x plus 3 into 2, 6y is equals to 18 into 2, 36. So now we have two equations. This is suppose equation 3. Okay, so this is suppose equation 3. The first equation is 2x plus y. The second equation is x plus 3y is equals to 18. And we have to solve this. To solve, there are different methods to solve the equation. One method is to make the coefficients of the first variable same. So we have this. See, we have both the things same. So what I'll do, I'll subtract. So when I subtract, 2x minus 2x will become 0. Y minus 6, 5 will become minus 5. Sorry, it will be minus 5, 5 and is equals to 8 minus 36. So if you subtract 8 minus 36, it's really minus 28. So you can see that now 5y minus 5y is equals to 28. So y is equals to 28 divided by 5 and this will be equals to if you divide 28 by 5 it will come 5.6. Okay, and now what we have to do, we have to uh, put the value of y in any one of the equation. So what we will do, we'll put the value of y in, suppose in equation 1. So it will be 2x plus 5.6 is equals to 8. So 2x is equals to 8 minus 5.5.6 and this is equals to, suppose if we subtract 8 by minus 5.6, it will be it will be 2.4. So 2.4, 5.6 plus 4 is 6 and yes. Now 2x, so x is equals to 2.4 divided by 2, that is equals to uh, what will be the value? It will be 1 point. Okay, so y will be 5.6 and x will be 1.2. So this is how we solve the equation. See how much time it took to solve the equation. This is the equation that we have to solve and this is how we solve the equation and we get the value of y and the value of x. Now, just see the magic, how we do it in MATLAB and how fast it can be done. So in MATLAB, what we do, we use slash operator, this backslash operator. So this backslash operator will give the result. So how we'll do x equals to a backslash b. So a backslash b will be solving the linear equation and finding the value of x and y in a matrix. So I'll go to prompt and here let me mention that what are the values. First, we have to create the matrix. So let me first quickly write a is equals to 2 comma 1, 1 comma 3. A is equals to a is equals to 2 comma 1 semicolon 1 comma 3. I hope this is the value. 1, 2 comma 1, 1 comma 3, 2 comma 1, 1 comma 3. Okay. And now we have b is equals to, let us see, 8 semicolon 18. 8 semicolon 18. So we have this. Now we write x is equals to a backslash b. And you can see the value of x is 1.2 and the value of y is 5.6. How quickly it has been done? So we do not have to solve the equations using mathematical rules. It will solve it for you very fast. And here is how we have solved. You can see these are the steps to solve the equation, but in MATLAB, it can be done using only backslash. So you use backslash and get the result done. So this is what we have to discuss today in today's session. Try to go through the video, practice it. We have also given some hands-on uh, for your practice. Go through them, try to practice, become an expert so that in the coming session, we'll explore some more thing. Thank you very much.